Hello, let's continue with our logic gets. Today we're going to look at the AND gate. Last time we talked about the NOT gate, which we said it has got only one input and one output, whereas if we input one, our output can be a 0, or if you input a 0, then our output can also be a 0. So today we're going to be talking about the AND gate. So on our AND gate, so I'm going to be using I'm not sure if this is going to be visible. I'm going to be using the mouse as my board. So okay, so today we're going to look at the AND gate. Okay, so the AND gate, what happens with an AND gate? We have two inputs and one output, which means, or what does this gate does? What it does is, when you first input a 1 and then the second input is also a 1, our output will be 1. So our logic gate will be drawn like this. So it will be, just draw it like a cup. Okay, then we have two inputs. One input is an A and the other input is a B. Then our output will be X. So X will be our result. So what it means is, when the first input is 1, if you input a 1 here and the second input is also 1 here, you're also going to get a result as a 1. So otherwise the output is what? 0. If you input a 0, then you input a 0, then you're going to get an output of 0. So this can be represented on a truth table. Or before I go to the truth table, talking about the AND gate, when using an AND gate, the output, which we said is an X, this X here, will only be high voltage if both inputs A and B are high voltage, which means a 1 and a 1. This means that X, this X is our result, will only be 1 if A and B are 1 as our result. Okay, so the logic gate has the labels A and B, which is here. A is the first input and B is another second input, and the output was always X. So we shall be representing our logic gates like this. A and B will be inputs, then X will be the output. This circuit is that A and B are 1. If A and B are 1, X will be 1. And if either A or B are 0, and X will be 0. So this will be like if you input 1 there and then you input 1 there. What's going to be our output on our logic gate? It's going to output a 1. But if you input 0 and input another 0 here, we're going to get a what? 0. So this is what we call the AND gate. So the AND gate can be represented on a truth table as follows. Let me draw it quickly here. So we're going to be having, okay, where we have we have our inputs. Sorry, writing with the mouse just difficult. Okay, but I'll do my best. Okay, we have where we have inputs. So we've got input A, which is this one. We've got another input B, which is this one, and we've got our output. So our inputs end here, then we've got our output. So on this output now, it means that we're going to have X as our output. So we have 4 possibilities here on our truth table. Okay, let me make 4 lines. We have 4 possibilities or 4 outcomes, which means that if a user inputs 0 and a 0, which is negative, our result is going to be 0. If you input 0 on A and 1 on B, our output would be 0. If you input 1 and 0, our output will be 0. If you input a 1 and a 1, you're going to get a 1. So this is our truth table. We have 4 possibilities or 4 outcomes from this logic gate. Okay, next we're going to move on to the next get, which is the OR get. Okay, on the OR get, what it does, okay, I'm going to scrape off this board. Now on the OR get, okay, let me get my pen. Okay, we're now on the next one, which is the OR get. Okay, what it does, the OR get, is when either or of the inputs is 1, it will input a 1. Otherwise, it will input a 0. So this can be represented as, okay, when you're drawing an OR get, okay, it's quite weird. Okay, it's like this. Then you go, okay, then you draw the inputs. We've got the input A, and we've got the input B, and we've got the outcome, which is X. So X will be our result. So this is the diagram of an OR get. So when using an OR logic get, the output X, which is this one, the output will be high voltage, which is on, if input A here or input B here is high voltage. So if it means if it is 1 here and 1 here, we are also going to get a what? A high voltage, which is 1. So this means that X will be 1 if A and B is 1. Okay, so we can also represent our logic gate in form of a truth table. So our truth table will be like this. We have input A, we've got input B, so these are our inputs. Logic gates, like the name says, this is logical. So sometimes if you have difficulties with these ones, you have to cram out some of these things because it's actually logical operations. Okay, then we have our outcome. Okay, on our outcome, sorry, or okay, it's okay, outcome or output, whatever, it's okay, but let's use output, which is most appropriate. Okay, then our output will be X. So it means we also have 4 outcomes or 4 possibilities here, which means that, okay, 1, 2, 3, 4. These are the 4 possibilities. If you input a 0 and B is also a 0, A and B, these are all zeros, our outcome is going to be a 0. If you input a 0 and a 1, our outcome is going to be a 1. If you input a 1 and a 0, you're going to get a 1. If you input a 1 and a 1, our outcome is going to be a 1. So this is the truth table which we are going to be using. So some of these things you are going to understand them as we do some exercises. For the moment I'm just explaining, we're going to do some exercises whereby we'll be referring to this truth table. For example, if I ask you what is the input of 1 and 1, just come to your table. We've got an input of 1 and another input of 1 here. What are we going to get at the end? 1. One input, so input A and input B, we're going to get 1. So if you get 0 and 1, so you make a reference to your table. So there is another way which we can also represent the truth table. For example, of when, I don't know which one will be flexible to you. I use 2 methods, but I didn't want to present the 2 methods at the moment. Okay, so we have our input on this side, which is input A. Then we also have another input on top here. Sorry, my mouse. Okay, then we also have another input here, which is input B. Okay, so what happens now? We have these numbers. If you input a 0, okay, let me put 0, 0, 1, then you have got 0, you put a 1 here on top, then you've got 1, 1, 1. So this means that if you input a 1, okay, let me change the color. If you input a 1, here is a 1. If you input a 1 and on the other side you've got, okay, A if it is 1, B is also 1. What are we going to get? So we're going to get 1 and 1. Our result will be 1. So where they meet here is actually the result. Okay, let's suppose you have input 1 and 0. So it means that you come here, we are going to input 1. A is 1 here, and B is 0 here, where they meet here. What is our result? It will be 1. So let's check on this table. I've got a 1 and 0. 1 and 0 is going to give us a 1. So if you input, for example, let's input 0 and 1. So you come to 0 here. Where is 1? Where they meet here. Input B is 1. Input A is 0. So where they meet is our result. So it will give us a 1. So a 0 and a 1 is going to give us a 1. A 1 here and another 1 on the B is going to give us an output of 1. So this is another way we can read our logic gates. Okay, let's move on to the last one, which is the XOR gate. Okay, I'm going to clear up this. The next one, which is the XOR gate. Okay, where's my pencil? We've got the XOR gate. Okay, the XOR gate is represented by this symbol. It looks like an AND gate, but it has got another line. We have to put another line behind. Then we've got our input and our our inputs A and B, and we've got the output, which is what? Which is X. So this will be our output. What it does is that, okay, so an XOR gate, or sometimes it's called an exclusive OR gate, has a slightly changed logic from an OR gate. Similar to an OR gate, the output X will be high voltage if either inputs are high voltage. However, in an XOR gate, if both inputs are high voltage, the output will be low voltage. So this means that X will always be 1 if A and B are different. So if A and B are different here, the output will always be a 1. Either if it is a 0 and a 1, then the output will be a 1. So this is the XOR gate. So this can be represented in a truth table. On our truth table, we can also have the inputs. Okay, then we have the output. Okay, we divide here. So we have 2 inputs and 1 output, and this one also gives us 4 outcomes or 4 possibilities, whereas we've got an A and a B, then this is our X, which is our output. So whereas 0, if you input a 0 and a 0, you're going to get a 0. If you input a 0 and a 1, you're going to get a 1. Input a 1 and a 0, you're going to get a 1. What other outcome is missing? Yes, the 1, 1. If you input a 1 and 1, you're going to get a 0. So this is the truth table of an XOR gate. Okay, or we can represent it again as can also represent it in this form, whereas we've got a 0 and a 1, a 0, 0, 1. Okay, then we have a 1, 1, 0. So which means this is our input A and this is our input B. So for example, let's take this one. If you input a 0, input 0 and input B, which is 0, the outcome is what? Is 0. So it means that coming to this diagram here, if you input a 0 and you input another 0 here, what are we going to get? Let me change my color so that I can okay, if you input a 0, this 0 here, and input B is also 0, what are we going to get? Here, a 0. If you input 0 and 1, our input here is 0 and 1, what are we going to get? We're going to get a 1. If you input which one is 1 and 0, 1 here, and input another 0 here, we're going to get a what? A 1. If you input a 1 and a 1, you're going to get a 0. Input a 1 and a 1, you're going to get a what? A 0. So this is our truth table which you can use. So definitely I believe that you're going to understand when I give you an exercise on how to do these logic gates. So these are the basics of the logic gates we've talked about. Looking at the last lesson we did, we talked about the AND gate, the types of gates, the AND gates, OR gates, XOR gates, and the NOT gates. So next we're going to be combining them. We're going to have more logic gates, which means we can join these two, the AND gate and the OR gate, the OR gate and the XOR gate, the XOR gate and the NOT gate, or we're going to join all of these four to make what we call a logic circuit. So for the meantime, let's try to understand. I will send you some notes on these so that we can keep up. Thank you for your attention.